Hello everyone, we, the students of Dr. D.Y. Patil Institute of Technology, are going to discuss some of the topics of software modeling and design in this video. The first topic is a component diagram. A component diagram visually represents the structure of a system's components and their interactions. It is mainly used in the design phase to illustrate modular parts of a system and their dependencies. The key elements in a component diagram are: first, components, represented as rectangles. These are the building blocks of the system. Second, interfaces, represent the way components communicate and interact, defining the services in a component providers or requires. Third, ports, represent places where a component interacts with its environment, sending or receiving messages. The fourth is connectors, represent how two components can communicate and exchange information. Fifth, dependencies, show that one component depends on another for functionality. The example of component diagram is an ATM machine. In the given example, we can see that the ATM machine, account, card reader, web page, client desktop is completely dependent on the bank database. Also, the ATM interface is an ATM transaction, and the client desktop's interface is client desktop transaction. The web page interface is online transaction. The second topic is a class diagram. A class diagram is a static structure diagram in UML that describes the structure of a system by showing first, classes, second, attributes and methods, third, relationships. It is a given blueprint of how objects interact and relate in object-oriented programming. The key elements of a class diagram are: first, classes, represent the blueprint or template for objects in the system, defining their properties and behaviors. A class diagram is typically represented as a rectangle with three compartments: the class name, the attributes, and the operations. Second, attributes represent the properties or data fields of a class, describing the characteristic of objects of that class. Third, operations represent the actions or behaviors that a class can perform, also known as methods. Fourth, relationships. How different classes are connected to each other is shown, such as through inheritance, association, aggregation, or composition. Fifth, multiplicities. Specify the number of instances of one class that can be related to a single instance of another class. The example of it is an ATM machine. As in this example, we can see that the bank is connected to the ATM as well as debit card, credit card. Also, it has an account section. Third topic is state machine diagram. A state machine diagram, also known as a state machine diagram or state chart diagram, is a type of behavior diagram that visualizes the states and transitions of an object or a system. The key components of a state diagram are: first, states, represented by rounded rectangles that depict the different conditions or situations an object or a system can be in. Second, transitions, illustrated by arrows that connect states indicating the flow between them. Transitions can be triggered by events, changes in conditions, or the passage of time. Events, occurrences that trigger transitions between states. Activities, ongoing non-atomic executions within a state. Initial and final states, marked with specific symbols to denote the start and end of the state. The example of it is a coffee vending machine. First, it is in the ideal state, then we insert the money and the preparation starts, and also sometimes it goes out of service and there is a stop state. Third topic is a sequence diagram. Models interactions between objects for a specific use case. Shows the sequence order of interactions. Represents how system parts work together to complete a task. Basic structure. First, timeline, top to bottom. Second, objects, shown as lifelines. Third, messages. Arrows between lifelines show interaction. Sequence diagram notations. First, lifeline notation represents objects in the system. Type, actor, user or external system. Entity, system data. Third, boundary, UI or external interfaces. Control manages the flow of interactions. Second, activity bars, vertical rectangles on lifelines show when an object is active. length equal to duration of activity. Third, message arrows. Synchronous, solid arrows. Asynchronous, line arrow. Return, dashed arrow. Create message creates a new object. Destroy ends with X. Reflexive, message sent to self. Fourth, loops. Use loop fragments to represent repetitions. Include a guard condition. Can set minimum maximum iterations. The example of it is library system. This diagram tells us about how we interact in a library management system, from requesting a book to updating the member records. The next topic is a collaboration diagram. Shows interactions between objects, roles via message exchange. Focuses on structural relationships rather than message flow. Used to explore object architecture in a system. The key elements are: first, objects, roles, represented by red triangles. Second, messages, arrows labeled with message name. Third, sequence numbering, shows order of messages. Fourth, optional lifelines, show object involvement duration. Features and syntax, emphasizes connections between objects. No tails on lifelines, less expensive than sequence diagrams. When to use: to model collaborations in use cases or operations, to analyze structural mechanisms, to explore object interactions and roles, for system level, use case level, or operational level modeling. The steps to create collaboration diagram are: first, identify behavior function to model. Second, discover class roles, objects, subsystems. Third, choose interaction content. Fourth, add messages with sequence numbers. Fifth, consider alternative scenario. The example of it is hotel reservation system. As here we can see user interface, hotel chain, hotel, reservation and confirmation via some messages like make reservation and is room, and also a self link. 1. Window, user interface, represents the user interface where the user initiates the reservation. Second, a chain, hotel chain, represents the hotel chain system. A hotel represents a specific hotel in the chain. A reservation represents the reservation being created. A notice confirmation represents a confirmation message. Activity diagram shows the sequence of activities from start to end, visualizes decision paths, parallel processes, and control flows. Useful in business modeling and workflow analysis. The key elements are activities and actions. Activity, a container for actions. Action represents a single step. Second, control flow and constraints. Control flow, arrow line showing sequence between actions. Action constraints, pre and post conditions added to actions. Third, nodes. Initial node, start point. Final node, end point. Activity final, flow final. Fourth, decision and merge nodes. Decision node, diamond shape, control flow splits based on conditions. Merge node joins multiple flowbacks into one. Fork and join nodes represent parallel processing, horizontal or vertical bars. Sixth, partitions. Divide activity diagram by role or department, can be horizontal or vertical, helps organize actions by performer. Example of it is passport management system, as we can see from starting to the end. Thank you.